Meet ISTQB Prep. Designed for future ISTQB certified testers, ISTQB Prep gives you everything you need to prepare effectively, from realistic exam simulations to AI-driven insights. Practice like it's the real exam. Get timed ISTQB-aligned tests featuring official sample questions so you know exactly what to expect. No more second guessing. Receive instant feedback with clear explanations, helping you understand why an answer is right or wrong. Stay on track with detailed performance analytics. Pinpoint your strengths, identify areas to improve, and watch your confidence grow. Get access today through GASQ or ISQI, whether as a standalone prep tool or bundled with your ISTQB exam. Study smarter, boost your confidence, pass your exam. Start preparing with ISTQB Prep today.
Hello, everyone, and welcome to this new session of the A4Q Testing Summit 2026. We apologize for the short delay on Stephen Platten's presentation. Stephen is an award-winning tester and QA with a passion for test improvement and development. And today he will talk about quality in the RAF and what it has taught him. Stephen, before handing over the stage to you, I would just like to remind the audience that they can ask questions using the comment section, and we will take them at the end of your presentation. Stephen, the stage is yours.
Thank you. Hi, everybody. Hopefully my internet connection is a bit more stable than a couple of minutes ago, and I'm coming across okay clearly, and the recording works for everybody. So thanks for the introduction. I'm Stephen Platten, also known as the Stoic Tester on LinkedIn and other platforms, such as the Ministry of Testing. I'm going to give you a short 30-minute talk on my time in the Royal Air Force, where I was an engineer, and the quality parallels that I drew into testing in my current career. So again, just a little bit of context. Stephen Platten from Inspired Testing. I'm one of the principal consultants there, working in our test architecture team, working with a whole multitude of clients in different areas and different avenues. And certainly my Air Force time has been one of the main things I've dragged across and brought with me. And hopefully you take something insightful from this presentation. So a little bit about me and my time in the RAF first. This is a bit of a background intro. So I was in the Air Force for just over 13 years. I did some operational tours, places like Libya and America and a few other bits and bobs. There's some very embarrassing pictures of me on this slide when I was much younger. I didn't have any facial hair. I was awarded some medals for some of my work we did overseas. And I think aside from the operational tours and the traveling, two of the bits that I really took from the Air Force, my time there, was the adventure and the training elements of it. So lots of different leadership and training courses, lots of different adventurous things that I would never have got to done otherwise. And then the last thing, which is mainly what the slides and the content is based upon, is the work ethic and purpose. So the work with the Air Force wasn't just the work, it was something much more deep than that, a lot of culture, history and ethos that was a shared experience that we all had during our time together. So why is quality something that is critical, not just as a testers, but certainly to the RAF? Why do they care about it? Why does it matter? So, as you might imagine, the Air Force works in some very dangerous environments with some very dangerous pieces of equipment. So, making sure that there's quality and high standards across the board in all aspects of engineering are incredibly important, not just from software, but also to mechanical engineering and aviation as well. So the way the Air Force considers that, it kind of builds it into its structure and its frameworks, its culture, is through three main principles. And these are based upon some of the Air Force's core principles. One is operational excellence. So this is something that is instilled in everybody when you join the organization. So quality assurance and working to a very high standard is expected and just encouraged. It's a very process-heavy organisation, so lots of process-led quality processes and procedure in place, such as QMS, and it also has ISO 9001 standards as well, that are implemented throughout the Air Force in all sorts of ways, from documentation through to engineering, logistics, etc. And the other thing would be there's a closed feedback loop on consistency of how the quality has been implemented. So there's lots of auditing, there's lots of performance assessments, there's lots of controls and measurements in place to make sure all the things they've put in place are actively working and adjusted. So things like aircraft investigations, things like that, constantly looking back at how they've implemented things and seeing if they can work as they move forwards. So the Air Force has two quality definitions, which may differ to our definitions as testers to what quality is, but these are pulled directly from some documentation that you can Google. So one is aircraft's air publication. So I'll mention air publications throughout the presentation. Air publication is just a document or a series of documents that the Air Force uses to instruct people on how to do things. In this instance, they have a manual for quality assurance and continual improvement, so the 100C-10. Don't worry, I'm not expecting you to read it for homework afterwards, but that basically sets out the policies around quality in engineering, such as logistics and other support activities. Secondary to that, the Air Force has quality is considered to be a system, so it's a quality management system, and that's about things like the audits and other pieces that I spoke about in the previous slide. So they have a very clear definition of it. They use industry recognized standards of what quality is, and that's built into the framework of how they do day-to-day tasks. Don't worry, I'm going to get to testing in a minute, I promise. So this is one of the main things I took from all the previous bits. So the Air Force has 4 key values: respect, integrity, service before self, and excellence. So the acronym RISE. So excellence is the main one that when I consider my time in the Air Force, when I looked at how we did quality. So excellence is something that underpins everything. So you have to be good at your job and doing things to an appropriate standard that is expected of you and you're trained to do. So I learned very early in my job that every single task that I did was very important and had to be done to a high standard. And that high standard, and the reason we're doing it for it, is a real reason. Even if the task might be quite mundane, there is a reason why those quality systems or quality expectations exist. So what is the Air Force's approach to quality, and what can we learn from it and take things from it as testers to see if it has any value to us in software development and engineering? So the Air Force's approach is basically built on 4 pillars. So if you think of a temple as an analogy, there's 4 pillars to the temple and the foundation that the quality is all built upon. And in the next few slides, I'm going to go through each of the pillars, talk about how they work and how they function. And then we're going to go into a practical example of my time in the Air Force of how the pillars were actually implemented and worked for real. So pillar 1 is standards and procedures. There's some other things in here, but I'm just trying to keep keep it concise for the slide pack. So this is things like engineering orders. So these are instructions that engineers have to abide by. You have things like NATO codes and standards. So the Air Force is part of NATO. So there's a whole quality management system that comes from NATO that we also work towards. There's approved maintenance procedures. So tasks are done in accordance with a clear procedure to a clear standard. So what does all that mean? It basically means all the work that has to be done in the Air Force is predefined and verified against a specific standard. Not in every instance, there are some edge cases, but generally speaking. So the reason for that, underpinning that, is it prevents variation and makes sure that the safety of the system, the quality of the system, is repeatable. Control as many of the variables as possible. The outcome should be largely within a predetermined outcome every time. So what is the testing direct parallel here? This is things like your testing frameworks, coding standards of practice, things like that. So the next pillar, and probably something I think we don't do a huge amount as testers that we probably should do more of, is redundancy and checks. This is the big bucket I'll put them under. So this is things like independent verification, peer reviewing of each other's work, and when you start working on aircraft, something called tool control, which is ensuring all tools are accounted for. Again, not necessarily a huge parallel to software development, but we'll get to that in a second. So why do I have redundancy in checks? It's to prevent a single point of failure. So if you're familiar with something like a Swiss cheese model of how errors or mistakes happen, they're trying to make sure those little holes don't line up, and this is a mechanism for them to do that. So it basically instills systemic cross-checking. So what's the direct testing parallel? This would be peer reviewing of each other's test suites and test cases, reviewing of regression suites, etc., etc. We do this on a day-to-day basis. Pillar 3, so this is documentation and traceability. Traceability is hopefully where the trick is to their testers. So this is things like maintenance logs, fault reports, and servicing records. So effectively, there's a written record every time any engineering task is undertaken in the Air Force. It's traceable back down to the individual that did it, the time they did it, and the authorization of the person that did it during that time. You can't do a task unless you're authorized to do so. So why have all that? Well, that enables you to audit, investigate, and improve when a system breaks down or an incident occurs. So what's our direct testing parallel in that instance? This would be assuming like you're testing evidence, your traceability matrices, or audit trails back to a user story in Jira or Zephyr or something like that. And then pillar 4, this is probably the biggest cultural one, I think I would say. So this is accountability and continuous learning. So as an engineer in the Air Force, when you did a task, you would sign that work off. By signing that piece of work off, it's a legally binded document to the event of something happening, like an air crash investigation or something like that. There's a written record of what you did and how you did it. It's effectively some evidence. What that also has built within it, it's like a lessons learned process. So if something goes wrong, there's a lessons learned process that's formalized and implemented. We try and track back, how did that incident or near miss happen? What can we do to improve it? What can we do to prevent it in the future? So instead of criticizing someone for making a mistake, the immediate cultural viewpoint is, how can we prevent that from happening again? What can we learn from it? So this allows the Air Force to have continuous refinement of its procedures and its training practices. So what's the direct testing parallel for this? This would be like QA sign-off, or you're going to CAB and you're presenting evidence for a release to go into production. You say, I'm comfortable that the testing has been done is to a satisfactory standard. We're kind of good to go. So as you can see, the 4 pillars, and they all have direct parallels, some more than others, to testing, and you can already start to see some of the parallels we can draw from it. So the main thing, the reason the 4 pillars or the temple idea works, is it's built upon the culture with the foundation at the base. So if people don't believe in the 4 pillars and the reasons why they're there, they don't work. So it's all well and good having standards if no one is willing to follow them. There's no point having checks if nobody does them. There's no point having documentation if they're not completed to a good standard. And there's no point having continuous learning if no one's willing to take accountability for a mistake. So the Air Force instills in you a culture, and that culture then creates the foundation for which the pillars can be built upon. And that's where the quality comes from. It's institutionalized. So how I'd like to summarize on the slide was you're not just following the rules because they're there, you follow them because you believe they exist for a reason that's going to benefit everybody. And the stakes are very high. So great in theory. What would that look like in actual practice? I'm not going to go into me changing an engine or something like that after this video assuring or an inspection. I'm just going to do a very simple engineering example of a real task that I did when I was still in the Air Force, and show you how the 4 pillars sit across that, and how you could then draw a parallel to that in a testing example or a QA example. So this is a scenario that I'm talking about. I used to work on an aircraft called the Typhoon, Eurofighter Typhoon, which is the bottom right-hand corner, one of those aircraft for a couple of years. And we're going to do something very simple, simples in quotation marks, routine maintenance. So we're just going to top up the gearbox on the aircraft like you would top up the gearbox, the oil in your car. Very, very simple. You're just going to add oil. But in the instance of what we're doing in the Air Force, a single mistake during this process could cause a potential grounding of the aircraft or a catastrophic failure of the aircraft in flight if the gearbox seizes or something like that. So even something as simple as putting some more oil in the aircraft is governed by very strict engineering orders, full documentation, a defined process, and then where applicable, independent supervision. So even though the task practically is actually very simple to do. If you look at the quality system built around it, it's actually quite complex, and you can see why the Air Force has such a high standard. So 2 slides coming up now. They're quite busy, so I'm going to try and talk through them a little bit so you're not confused. I would encourage you to try and read them. So bits of this, I've tried to break down the process of topping the oil up in step by step. So each step we do a thing, there is something to be learned from each step, and then we move on to the next step. So the steps are the boxes across the screen. You'll see people icons above each one. So there's a dark blue and a light blue. So the dark blue is referring to me as the engineer, and then the light blue is referring to somebody else who would be effectively checking or overseeing some aspect of the work that I am doing. This wouldn't necessarily be the same person in every instance, but it's just to give you an idea that there is other people involved in the process. So before any of the, I've tried to simplify this down into a couple of steps. There's way more than this, but we'll go with it. So the first thing would be to obtain, to me as the engineer, would be to obtain the appropriate air publication, so a document, and confirm the task that I've been given I am authorized to do so. So in the Air Force, you can't do a task unless you're authorized. Obviously, in our civilian environments, we don't work this way. In the Air Force, you do. So that underpins 2 elements of the quality system: standards and procedures, and accountability and learning. Because I might be not very appropriately trained to do the task, therefore I might need to do some learning or some courses or something to give me authorization. The next thing, me as the engineer, so who's doing the other check there? There's a more senior engineer who's checking that I have the right publication and I have the right authorizations. And then I'm going to perform a tool check. So I'm going to go and find the tools that will be appropriate for me to do the task in this instance. And that's to make sure the tools are suitable, they aren't damaged, they aren't contaminated, they are appropriate, and also the oil would be appropriate, as a good example. And again, there'd be a separate individual, a tool control system, who would make sure that I have all those tools available. And again, at the bottom, you can see the 2 pillars that applies to: your redundancy and checks, and documentation and traceability. The next thing is confirm the aircraft's identity and the component serial number of the thing I'm working with. Funny enough, all the aircraft look the same, so it is important to get the tail number to find out you're on the right aircraft, and you've got the right one. Don't worry, I'm going to draw parallels to all of these in a few slides, so to show you where the direct read across happens and where the lessons can be learned. But effectively, I've got to identify the correct aircraft and the right component I'm doing. Again, standards and procedures, where that quality principle comes from. Next one, we're going to look at carrying out any safety isolation procedures we need to do to make the aircraft safe to work on. So much like you would do with your car, you would probably turn the engine off, make sure you're parked up safe. Aircraft is the same, except there's obviously a little bit more to it than that. So again, I'm going to make sure the aircraft is safe, and someone is there going to be with me, making sure that I'm okay. Very rarely would you work on an aircraft by yourself. Normally there's someone around or with you on each task, and that's mainly for safety reasons. So I've got the publication that I should be following, the process. I've confirmed I'm authorized to do the task. I've confirmed my tools are all good, and I've confirmed the correct aircraft and the thing is safe to work on. What do I do next? I would inspect the area and the oil servicing point, which is effectively where the oil will be introduced. So why would I do this? This is again just to make sure that the thing I'm about to do is safe to it's safe to happen, but also there's nothing wrong with the area before I do that inspection. So if you think of it from a test analogy, you wouldn't run a test unless your environment was correct, your test data was prepped, and you had the right version of the code base. Again, that draws the standards and procedures and accountability and learning. Get able to do this by myself. The next step, again, there's two-person process here, but not necessarily the same person, would be to select the correct oil type and verify the batch. So I can't just go into a DIY store, buy a can of oil, and then just plug that into an aircraft. Funny enough, aircraft oil is very specific, and we have to worry about things like the batch number or other bits of information about the oil to make sure it's the appropriate one to use. We can't just grab something off the shelf. So that's the first part of the process. As you can see, there's already quite a lot of steps, and I haven't actually really done anything yet. I've just kind of got there, looked at the aircraft, and I'm about to move on. So part 2. So you notice there's a bit of a colour difference on this one, which is one of the rectangles is blue, and I'll talk to why that is in a second. So next thing, I'm going to top up the oil using a calibrated dispenser, so a calibrated tool. So I'm just going to make sure I have the right tool and I'm doing it appropriately. and then stabilizing the oil levels and just rechecking them to make sure they're good. So I've topped the oil up. I'm just going to check the levels. The levels look good. So again, redundancy and checks built in. The next step, this doesn't always happen, but happens more often than not. This is an independent inspection, or what's classified as a dual sign-off. So this would be when a task is critical enough or requires an additional level of oversight, it's mandated that you have to have an independent inspection of the task that's just been carried out. What does that mean? That normally means somebody from a completely different trade within the Air Force or from a completely different part of your working environment would come and assess your work. They don't know the work that you've done. They don't know anything about it. They're independently inspecting it from their own perspectives and quality. And once both parties are happy, the independent and myself, that we would sign that work off to say it was completed. Again, doesn't always happen, but very important. When it is critical to do so, you have the independent inspection. Next thing, so the oil's all topped up. I've checked the levels. We've signed off the work to say we're comfortable. We clean the work area down, so we'd make sure the environment was good to go. Refit the access panels, and then do a post system check. So just making sure everything is in place, is correct. So there's nothing untoward. I've got everything comfortable when I finish, and then we're going to complete that whole step with completing the documentation. So this is what's called an F700, which is effectively like the aircraft logbook that follows the aircraft around. Inside that book, I would sign to say the work has been carried out. I would account for things like my hours, what documentation I used, etc., etc. And that would also be potentially oversigned if necessary. So as you can see, there's lots of different steps there involved for what is effectively a very simple task. And hopefully you can see where the quality is built in at every single level in different ways relating to the pillars. So if you take away just one thing from that, before the parallels, is that it's not necessarily about the task or the job that you're doing. That's not what quality is. Quality is about making sure that everything is done right and recorded right and verified right against a standard that's kind of pre-agreed upon. So every step in the Air Force in this example has a procedure or process. It has evidence and there's accountability of the task. If you think to yourself as testers, how often is that the case? Probably not every time, right? Even the smallest routine task, like the one I give you an example of, has the same level of care as a task that's much more mission critical. Now, you might think that's wasted effort, but it's not. It's to encourage a culture that the task that you're doing and the quality of the work that you're doing is just as important as the actual task. So if you think of that mindset and flip it into testing, especially around something like a complex system, you treat every check or test as if something really depended on that outcome, either the user being able to complete the task, or if it's a safety critical system, like within infrastructure, like someone's safety could depend on it. So the Air Force tried to say this matters and how it matters. Quality matters, and this is how we do it. So hopefully the same applies in testing, and you can see that, and that parallel that pulls across between the two things. So I promise you I'll try and do a software testing parallel. So I've taken the steps that I've just outlined in my example, and I'll show you direct cross parallels to testing and where we can see those two things line up. So starting from the top, if you look at the obtaining the air publication, so this is a document, and in theory you could do the task. Direct test equivalent would be like confirming your test plan, your scope, and things like your entry criteria into a test phase or sprint. Tool control, this would be something like checking your test environment and the tool that you're using, maybe the automation framework, is fit for purpose and at the appropriate version and standard. Aircraft identification, so again, this is be verifying things like the environment build, the test data that's being used, or the build version of the code that you're about to test. Safe isolation, so this would be things like protection of productionized data. So we shouldn't be really testing with production data, making sure that's protected and anonymized, and then also disabling any potential risky automation frameworks that we don't want to run during our test phase. Next step in the Air Force one was to area inspect. So remember, I'm checking the area where the oil is going to go. This would be something like a smoke test or environment validation. So it's a pre-test, for want of a better description, to make sure I can start my formalized tests. Oil type verification, so making sure the oil was correct. This is about making sure that we validate our input and output steps of each test case, and making sure the configuration of a test suite is done correctly and it runs in the right order and sequence. We control how the top-up is being done. So this is executing test cases in a logical, rational order for a specific reason to get those outcomes that we want. We might want to potentially rerun those tests, would be the next step, which relates to rechecking your levels. Independent inspection. This is something I think we should do more as a community. Can be very difficult if you're a solo tester, but you can ask other people that are non-testers to come do this for you, which is to peer review and have an independent review of the work that you've done to make sure you're comfortable with it. So I have a number of analysts that are working for me with my current client. If they get into a regular kind of cadence of, we've run the test, Steve, there's the results. If you want to go have a look at them, please do. And I encourage my team to do peer-to-peer and me to review it as well. We're next going to do the cleanup and resecuring of the area in the aircraft. What is the read across for testing? This is closing the environments down when they're not being used and tidying up any evidence or collateral that might be created as part of our test cases. This could be videos, log files, etc. Making sure they're correctly named and stored appropriately. System check. So again, this could just be like a regression suite that you run post-test conditions or maybe a sanity check. And then finally, documentation. Hopefully, we all do this to some degree or another. Record results and sign it off. This could be in Jira, Zephyr, ADO, please say a test management tool preference. So you can see there's direct parallels in each of the steps in my example to a specific testing task and how those read across. Hopefully, I've managed to outline the Air Force that quality is considered as everyone's job, but we all have different parts to play. And I think as QAs, we also need to get across that. Quality is everyone's job, it's not just ours, it's everybody's. The Air Force uses process to ensure that the safety and that discipline is there with some confidence. They use verification to make sure they're not making assumptions. They see documentation, not just as paperwork, but that proof that something has happened. They encourage accountability to build pride in the work that you're doing, not necessarily to attribute blame to somebody. But they also run something which is very unique, which is a just culture, which is something that runs for the whole organization. So you're not justly criticized if something goes wrong. The why that issue happened is looked at in detail. So again, if we zoom out back to our pillars again, where can we draw the parallels to the 4 pillars? So standards and procedures, there are test frameworks, our coding standards and our exit criteria. Redundancy and checks, that's our peer reviewing, layered test levels as an example. So our test pyramids, things like that, and varying our tests. Documentation and traceability, this would be our test cases, our results, our reports, KPIs, metrics, dashboards, things like that. And then our accountability and learning, this is a sign off, again, post-release metrics, maybe retrospectives and lessons learned. I just want to give you a little bit of an insight. That's the end of the presentation. I've got 1 or 2 more slides for you and ask you some questions. So just to summarize, I'm known as a Stoic Tester on LinkedIn and other platforms. If you search for me, that's what you hopefully found. And I always review things through the lens of Stoicism, which you want to learn more about, please look me up. Effectively, I look at controlling what I can, accepting what I can't. I respond with a clear response as much as I'm able to, and I learn and improve for the next time. So you can see those parallels are really clear across to the Air Force and to my current role in testing. If there's no other takeaways that you get from this, hopefully you would understand that I wouldn't get into an aircraft that I wasn't willing to sign off it myself. So maybe we shouldn't use software that we wouldn't be willing to use. Maybe that's the line where quality can be drawn between us. Thanks for listening to my conversation. We've got a couple of minutes left. If there's any questions, feel free to use the QR code there if you want to help me on LinkedIn.
Thank you, Stephen, for this presentation. As you said, you can ask your questions in the comment section. We already have a few ones, so let's start. What is the biggest lesson you learned on quality while in the RAF?
That if you don't care about it, or people don't care about it as a collective, any systems or mechanisms or processes you create won't work, or they will start to break down. That doesn't necessarily mean that everyone has to care to the same level, but we all have to agree that it's important. Otherwise, it'll get dropped to the moment's notice. As soon as things get difficult, those processes will not be followed. People will go around do loopholes. So I think culturally is the biggest thing why quality doesn't work in organizations and clients. That's what I'd learned.
Thank you for this reply. Okay. How do you make your stakeholders care as much about quality as the RAF?
I think this comes to not catastrophizing, but showing people what can happen if quality isn't considered. So making the risk clear and present and upfront what poor quality can lead to. So production as instance, bad reviews from customers, loss of revenue. You need to take those real world examples and present them upfront. The speed to market and release isn't necessarily the be all and end all. You can release something very fast with poor quality, which tanks your user base. So to make people care, you need to show them the so what. The so what is what are the negative impacts of poor quality releases of products.
Thank you. And we have one last question. Where would you start with your team or yourself on considering quality?
I would probably start with an agreement on what quality is as a collective and where it fits in with your organization's goals. So you can't just create a big quality framework and definition if it isn't in line with what the business is trying to do. If the business is trying to be the best in the world at activity, there's no point in putting a quality framework in place that prevents that from happening, because it isn't going to work.
Thank you.
Thanks.
We've reached the end of this presentation. If you have missed all the other presentation, you can find them on our A4Q YouTube channel. Thank you, Stephen, for this presentation. And don't forget that you can vote for your best speaker and best presentation also. So you have the QR code here to go directly to Stephen's page if you would like to vote for him. Thank you for attending the Testing Summit, and we hope to see you soon.
Thanks, everybody.
Meet ISTQB Prep. Designed for future ISTQB certified testers, ISTQB Prep gives you everything you need to prepare effectively, from realistic exam simulations to AI-driven insights. Practice like it's the real exam. Get timed ISTQB-aligned tests featuring official sample questions so you know exactly what to expect. No more second guessing. Receive instant feedback with clear explanations, helping you understand why an answer is right or wrong. Stay on track with detailed performance analytics. Pinpoint your strengths, identify areas to improve, and watch your confidence grow. Get access today through GASQ or ISQI, whether as a standalone prep tool or bundled with your ISTQB exam. Study smarter, boost your confidence, pass your exam. Start preparing with ISTQB Prep today.